5 is getting substituted in synthetically. Our coefficients are 1, -5, -9, 45. Notice we're not missing any terms. Sweetness. Drop the leading coefficient down and multiply, add, multiply, add, multiply, add. Good. That's our remainder. The constant term is -9. The x term is 0x, and the x squared term is a 1x squared. So really we have, now if 5 is a 0, that came from the factor x minus 5. So in factored form, this polynomial right here equals x minus 5 times x squared. There's a 0x term there, so minus 9. To factor this, it's only 2 terms. That's weird. So I think difference of squares. Can I square root each of these? Yes. Square root of that is x. Square root of that is 3. So that factors into x plus 3 times x minus 3. Difference of squares. Brought the x minus 5 down. We want to know what values of x make this function equal 0. Well, 5 makes this first factor become 0. -3 makes this factor become 0. And +3 makes the last factor become 0. So those are our solutions. Hip, hip, hooray. Let's try the next one. Alrighty, so -5 is getting substituted in. Coefficients are 1, 12, 47, and 60. Drop down your leading coefficient. Multiply, add, multiply, add, multiply, add. Whew. No remainder. Constant term, x term, x squared term. So if -5 is a 0, that comes from the factor of x plus 5, because -5 plus 5 is 0. So this polynomial factor would look like x plus 5 times what we have here, x squared plus 7x plus 12. So we try to factor this further. There's no GCF that I can take out, so I'm looking for numbers that multiply to 12 and add to 7. That would be 3 and 4a. So we already know that x plus 5 is a factor, but we can factor this further. So x plus 3 times x plus 4 are additional factors. So then the question comes in, what makes this polynomial, which by the way, this polynomial, ooh, I thought I changed colors. This polynomial right here is in standard form. Down here, it is in factored form. What makes it become 0? What are the values of x that, all the values of x that make this polynomial become 0? Well, look at your factored form. -5 would do it. Seriously, folks, if you plug in -5 in here for x and punch that big polynomial in your calculator, you will get 0 as an output. Same with -3. Same with what makes this factor become 0? -4. Bada bing, bada boom. Drop down your coefficients. Not missing any terms. Okay. Drop down the leading one. Multiply, add, multiply, add, multiply. Good. No remainder. Constant term, x squared term. So if -3 is a 0, that came from x plus 3. So in factored form, this polynomial is initially x plus 3 times x squared. That was a 4x plus 4x plus 3. We want to know what values of this polynomial equals 0. But before we can go there, let's try to factor this x squared plus 4x plus 3 further. Looking for numbers that multiply to 3 and add to 4. That's a tricky one. That's 1 and 3. So that's the same as x plus 1 times x plus 3, or vice versa. And x plus 3 is already another, wow, we already have x plus 3 down there. That doesn't mean it's wrong, folks. We're okay. What values make this function equal 0? Now that it's in factored form, it's easy to see that -3 will be a 0, -1 is a 0, and -3 is a 0. So I realize that I have -3 written down there twice. That's okay, just leave it. It's all right, no big deal. Last one, I think, right? Yeah, all right. So let's do this. -2 is getting substituted in. We have 1, 3, -18, -40, and 0. Notice there's no constant here, so we have to put a 0 in. This isn't a constant. Remember, they've used semicolons to tell you where your 0 is. So drop down your leading coefficient, multiply, add, multiply, add. Oops, I think I was ahead of myself or behind myself. I don't know. Add, multiply, add. There is no remainder. This is your constant term. That means that this negative 20 is your x term. The first one is your x squared term, and the next one is your x to the third term. If negative 2 is a 0, that came from the factor x plus 2. So this polynomial in factored form is x plus 2 times x to the third plus x squared minus 20x. So now we try to factor this polynomial even further. Well, I know I can factor an x out. So I'm going to factor an x out of that green thing. So I have x plus 2, I'm just dropping that down. Factoring an x out, I'm bringing that out in front of this, which means now I actually have x squared x negative 20. So I'm looking for numbers that multiply to negative 20 and add to a positive 1. Let's not use a crayon here. Bum, bum, bum. Numbers that multiply to negative 20 and add to 1. Positive 5, negative 4, right? So that means that this x squared plus x minus 20 is really written as x can be factored more completely and written as x plus 5 times x minus 4. We want to know the zeros of the polynomial. At what values of x is the polynomial 0? So solutions are, now that we see it in factored form, negative 2 is definitely a solution. 0 makes this factor equal 0. Negative 5 makes this factor become 0. And 4 makes this factor become 0. Those are my solutions.